welcome to your first laboratory in digital communication. The title of the first experiment is pulse code modulation and demodulation. These are the two references. One is from the textbook and one is a YouTube video. I am providing the QR code for this YouTube video at the end of this presentation. When you talk about in general pulse modulation, you are having four different types of pulse modulation: pulse amplitude, pulse width, pulse position, and pulse code modulation. So the focus of this particular experiment is pulse code modulation. However, for the sake of completeness, the other three modulations are mentioned here, and the concept of those other three modulations is explained in this particular diagram. This is what is your analog input signal, and you are taking samples of that particular analog signal at regular interval. Here that regular interval is shown T, and 1 upon T will be the sampling rate, sampling frequency. So as you know, when you talk about pulse amplitude modulation, whatever sample you are taking at one particular instant, depending on the height or amplitude of that particular sample, the amplitude of the pulse is decided. So the more the amplitude of the sample, the more will be the amplitude of the pulse. When you talk about pulse width modulation, here the amplitude of the pulse will not be changing. However, the width of that particular pulse will change as the amplitude of your sampled analog signal increases. So you can see here, as the amplitude of the sample increases, the width of the pulse over here, it goes on increasing. In pulse position modulation, actually two pulses are transmitted. One pulse will be transmitted at the sampling point, and the another pulse will be transmitted depending on what is the amplitude of that particular signal. So the position of the second pulse that decides the amplitude of the signal. I will not be going into detail for those three: amplitude modulation, width model, PPM and PWM. However, as I said, at the end there is a YouTube video, and you can go through that YouTube video for getting a detailed information about those three types of pulse modulation. The focus for this particular experiment is pulse code modulation. It is one of the most widely used techniques for digitizing information signals for electronic data. PCM signals, they are transmitted serially, that is whatever is the digital data that is transmitted serially. And out of those two ways to generate, we will be focusing on the first way of generating the PCM, and same way is actually implemented in the hardware kit which you will be using for performing the experiment on pulse code modulation. So what is the method of generating the pulse code modulation? We will be using sample and hold circuit and traditional A to D converter. So whatever individual samples you will get, those samples will be converted from analog to digital format, and then that 8-bit or 16-bit, whatever is the resolution of that A to D converter, those samples will be converted uh, in the serial way. So those samples will be given to the shift register, and those shift registers will transmit those 8 bits or 16 bits serially one after another. So this is what is the demonstration of pulse code modulation. Here x-axis is representing time. We are taking samples. This is what is the analog signal which we want to transmit into a PCM format. So we are taking the samples of that particular signal at regular interval, and whatever amplitude of the sample we get, that amplitude we are converting. So here the quantization will be done. As you know, in A to D converter, after sampling the quantization will be done, and after doing quantization, that particular amplitude will be converted to the nearest equivalent level. So here the equivalent voltage levels are shown, right from voltage 0 to voltage 15. So individual amplitudes after quantization, they will fall to one of the voltage levels, either 1 voltage, 2 volt, 3 volt, 4 volt or 15 volt. And then after getting that voltage level, each sample will be converted into a binary form. So if this particular sample is of 4 volt, then that 4 will be converted to 0100, that will be A to D converter. This is what is the digital data, and this digital data will be shifted serially by the shift register, and that is how we will get 00100 at the output, one bit after another. So this is what is the block diagram for pulse code modulation. You have the analog signal, we give it to sample and hold. It's actually sample and hold and ADC, they are combined together. So whatever sample will be taken, that sample will be given to A to converter, it will give the digital output. And then with the help of shift register, you give the clock, this shift register will shift the data serially at the output. So in this experiment, this is what you will be experiencing. Means already these kits are available for PCM transmission and PCM modulation and PCM demodulation. You will be giving at the beginning the analog signals, DC voltages at the input, and here in the kit at each of the ADC output, LEDs are connected. So by observing whether LED is on or off, you will be able to check what is the binary format, what is the digital equivalent of that particular input analog voltage you are getting, and then that digital equivalent will be shifted into the serial form, which you can monitor on the DSO. So please scan this particular QR code and go through the complete video which is available on the YouTube. Thank you.